guys, I'm glad you're all here. Thank you very much for joining me. Got a live view from the Old Faithful webcam, looking back here to the basin, and we got the Firehole River over here. Some activity going on. For some reason, they're not reporting the earthquakes that happened last night or today. The last earthquake they did report was in an area they call the Silver Gate, a magnitude 1.0. And that was about 8 miles below sea level. That was it. Then on the 7th, they mentioned 1, 2, 3, 4, 5, 6. 6 for, yes, the 7th, which was Tuesday. I don't know why they're not reporting them all. So here we have Mary Lake on the left. We got borehole 207, which is Madison River area, next to it. Western boundary, and then borehole 208, which is Yellowstone Lake. So I'm going to go to the Madison River one, because this one is marked in red, and this the most recent one, almost at 6 o'clock Universal Time, 5:59 and 30 seconds. So 11:59, almost 12 p.m. going into the next morning. And this comes in as a magnitude 2.05. Not being reported. It's probably one of the larger ones that are here on the borehole. We got another one marked in red at 3:54 Universal Time. That would have been at 9:54 p.m. last night. And that one comes in as a magnitude 1.97. And we got another one marked in red at 3:51 Universal. That would have been at 9:51 p.m. last night. And that one comes in as a magnitude 1.75. Okay, let's see what else we might have in red here on the borehole. That's it. Okay. Again, this is the Madison River area. Alright, so I had to shut down and restart the program. It was screwing up on me. I don't know why. I want to go to Mary Lake, and we'll make that bigger. And you can see we got all three here, also marked in red. Let me bring it down and show you what it was doing when I pulled the files a little while ago. Yeah, again, tectonic in nature. Yeah, see how this is rounded here? This is an indication of tectonic movement. Yeah, and the sharpened points. Yeah, the faults are moving. Let's go to the spectrogram. Okay, and there's other ones here that I noticed. I'll start with this one right here because it's on multiple monitors. Again, this is Mary Lake at 6:52. Oh, excuse me, 5:52. Okay. So here we have the borehole 207, which is the Madison River borehole. Next to it is the western boundary. And then borehole 208, which is Yellowstone Lake. And then this is Mary Lake. So I'll go to the borehole there for Madison River. That's probably got the best signature. Let me fix that one. Well, actually, the Mary Lake one is the better signature. This one's got a little bit of a P wave here at the Madison River borehole. So we'll go to the Mary Lake. So that comes in as a magnitude 1.71. If I go to the borehole, I get a magnitude 1.75. All right, and there was another one right here at 6:27, so that would be 12:27. Now, the times that I'm giving you is Central Daylight Time, and this would all be Mountain Time. So just take off an hour. Again, tectonic and movement. I've been seeing a lot of tectonic lately, and, well, today. and the last couple days that I've been watching. Not so much magma movement. So this one too would also be a 1.7. Actually a 1.73, but yeah, who's gonna worry about the whatever, point whatever, 0.5, 0.3, 0.2, but it's still a 1.7. See this one here at Mary Lake? Yeah, all three are in red. And then it kind of looks like, let's double check. Yeah, a little pulsating. Yeah. Again, all tectonic. We got a little popping of the rock over here. And let's go to the spectrogram. Okay, we'll come up a little bit. Yeah, I noticed this one was on... it's not going to show me. Huh. Darn it. Let me see if I can get that on a different monitor. Alright, western boundary. I did get it. I had a hard time downloading the different data to put into this program. It only lets me put in so much data, but I'm going to take you over to the stream view. This is what I was trying to show you. Right there we got, you can see here, borehole 207, the Madison River. The western boundary's got a real good signature. Yellowstone Lake, it showed up. And also for Mary Lake. So we got it on 4 different monitors. And let me extract that. Okay, and this was yesterday. Probably 6:14. And they're not reporting it. I don't know why they're not reporting it. Look at the heat that came up. Again, this is the western boundary. This is the line of melt, pockets of melt. They're saying now that they got pockets of melt about 20%. And you can see it's closer. There is areas only about, last I heard, which it could be worse, 600 feet under the ground where people are walking. Yeah, where there's, pockets of melted rock. The more monitors that I download data from, the less I can put on here. And you can see I got 4. I did have 5. I did have Denny Creek. But I was so limited in how much data I could download to this program, I had to take it off. So this is borehole 208, which is Yellowstone Lake. You can see we got 3 right here marked in red. There's that one. It's got a little P wave on it. Now that one there, yeah, that's harmonic tremors. Okay, and same with that one. Harmonic tremors, it's picking up in the borehole. Here we have documentation about that borehole. It's got a cap of cement, tilt meter pipe. It says 82 feet, 6 feet of casing. 397 feet to the bottom of the casing. And then the monitor for the seismometer is 487 feet. That's my dyslexia. Getting everything backwards. And then the strain meter is 529 to 535 feet. Evidently, when they were first putting it in, they had a blowout. And it said they had a huge blowout at 660 feet. And then they filled it in and capped it off. Alright, then in 2007, October 27th, it said they put in a strain meter and found a dent in the cable and all that stuff. Let's see what else they say. Finally got the borehole put in on October 30th. Installation was very difficult on the 31st due to weather, probably snow and cold. They had to flush the hole with 500 gallons of water to make sure the hole was clean. Due to line freezing, it took a lot longer than it should have. 2009, the tilt meter was leveled. They did a reboot and a patch. Power box was replaced in 2010. Yeah, they have had all kinds of problems. 2011, the tilt meter was replaced. Lost power, the IDU in 2014, and they put in a new satellite dish. And it looks like the last maintenance was in 2019. Might want to take a note of this image here. I believe this is the strain meter showing the direction of strain that's occurring. You know, channel 0, channel 2, channel 1, and channel 3. Then here on this monitor shows the different directions. Looks like channel 0. Yeah, might be something wrong with that. Dark blue is channel 0. Okay, red is channel 1, channel 2 is the green, and channel 3 looks like it was maybe screwing up or something happened. So that would be from southeast a little bit, going northwest. Yeah, no tilt data available for the last week. And the last month. And then this goes back to 2008. This is where they readjusted the different machines. You can see here in 2014. We'll go back to 2014 and see what it says. Yeah, that's when they had all kinds of problems. They put in the new satellite dish and re-leveled the tilt meter and installed Verizon CDMA and removed the Cisco monitor. Tilt meter was recording exceptionally high levels of tilt. Yeah, in 2014. Try to replace it, but the spare would not auto level, huh? Okay, USGS owned tilt meter. And so Madison River strain meter, again station or channel 3. All right, for this borehole it shows channel 3 from southwest going northeast. You can see it right there. The strain meter is 681 feet. And the seismometers is 666 feet. They didn't have the problems like they had with the other blowhole with blowing out and having to drill a new one. This was put in 2007. And it goes on. Keep in mind about that borehole for the Madison River area. There's another one that stopped working in 2008. And I'm going to go into more detail about that, why it is so important to have those monitors working. Yeah, several problems also in 2014. Yeah. I wonder if they had a lightning strike or something like that. February 6, 2018. No tilt data since December. And that's the last date on here for any type of maintenance. All right, the tilt for Madison River. Yeah, it's going up. This is for the last week. And they have the disc. And I've talked about that before. The last month. Look at this. Yeah, going up. Not surprising. I did hear there's been uplift there, but have not been able to find the article about it. And then, here you can see the Madison River's constantly going up, up, and then, let's see, 2014, wanted to see, they readjusted it, and this goes back to 2011. The Norris Geyser Basin stopped working around the 28th of last month. Got very little data. It was, fairly flat, not too bad, but you can see here the uplift when it was first put in 2014 was steadily rising. And let's take a look at the notes. So we have no tilt meter working for this location, and no data, no nothing. Yeah, it's 367 feet deep, not very deep. So of October 2013, it says Enriched Park engineers were able to negotiate access for a few days during the government shutdown to complete this process. Makes you wonder why they work and install things when it's so cold, and here it is October. Says very cold in the morning. All the plumbing to the water tank and cement pump were frozen solid. Spent a good portion of the morning thawing parts. There was still a fair amount of snow on the site, but with chains were able to get the flatbed with cement and water trailer up and down the hill. Yeah, why do they work in the winter? Why don't they work in the summer? October 6th, installed radio shot between borehole 205 and 950. Tried to adjust the DH temperature. Hole is too hot for dash pot temperature adjustment. Need to change the resistor on the logger board. Gives it in volts, but not temperature for the, but not the temperature, I should say. Borehole 950 is a replacement for borehole 205, which was struck by lightning. I don't know why they never went in and just pulled the stuff out, replaced all the equipment. When you did the hard part, which was drilling the hole, I don't know why they didn't go back, because this one, borehole 205, is very important. So here you can see 205 and 950. Fairly close to the same location by the Gibson River area. Alright, so here's the location of borehole 950. And this is the Norris Geyser Basin area. Here it says borehole 205 removed inoperable. And I believe that was in 2011. Alright, so what I'm looking for, there used to be a borehole over by what I call Grizzly Creek, or the Grizzly Creek Fault. I believe that's it there. Let me see. Alright, I found it. Okay. This is Grizzly Lake. And this is an area where when they had the last major eruption, the basalt came up so hot and so fast, they had a mixing of the rhyolite. It mixed so much, notes that I found said it looked like marble cake. What was real interesting is new research shows that this mixing happens prior or during a major eruption. And then another interesting thing that I found, let me see if I can find the notes on that. Well, I can't find it, but there was lava that actually had no water in it, which is really unusual. No fluids at all. But another thing that I found that was really unusual, which shows subduction of the Pacific plate going underneath the North American plate, was the Lava Creek eruption. That one occurred about 640,000 years ago, and it contained minerals that are typically found in ocean crust, such as titanium-rich magnite. And it was unusual because Yellowstone is located in the middle of the North American continent, far from any oceanic regions. This was the only eruption that showed the presence of oceanic minerals. The subduction event would have caused magma. The subduction event would have caused magma to rise up from the Earth's mantle and mix with seawater, which in turn would have introduced oceanic minerals into the magma. It's worth noting that the Lava Creek eruption is notable for containing oceanic minerals, and it is not the only example of such an occurrence. Other volcanic eruptions around the world have been found to contain minerals that are typically associated with oceanic crust, such as the Mid-Atlantic Ridge and the Aleutian Islands. However, the Lava Creek eruption is perhaps the most well example due to its location in Yellowstone National Park and the extensive research had been conducted on the eruption. So of all the volcanic eruptions, this is the only one that came up from the mantle showing oceanic materials. And I thought that was interesting for the lava creek tuff. And it had the mixing, which, it was over a large area, the mixing of the magma. So here we have one image of the rhyolite and basalt mixed lava. Another image about how rhyolite is formed, coming up with the basalt. The basalt comes up, it cools down, it heats up and cools down and it separates. And so we have the rhyolite at the top that I've talked about. Now this is the caldera rim, and here we have another plume that I've talked about, coming up from the Snake River Plateau of basalt. And let's bring this down so you can see it. Alright, I found it. This is the area when the magma erupted at Bisca Basin. There's actually 3 eruptions here, they found out later. They thought it was just one area of eruption. Now you see the Firehole River and all these different geysers. And this is an area where the lava had very low water in it. Alright, calderas are important loci of large-scale fluid rock isotope exchange. They often cite how the water percolating, heating up is what causes most of the earthquakes there in the Madison River area. The best and most extreme example of low water rhyolites occurred in the Yellowstone Plateau volcanic field, Wyoming, where dramatic depletion occurred and magma erupted after the caldera-forming eruptions. Such extreme depletions are not observed anywhere else in the world. Smaller decreases of 1 to 2% of the water are more typical for magmas and other caldera complexes and associated with plutonic bodies. Depletions are yet to be found in other calderas. Based on isotopic compositions, geologists estimate that to cook a Yellowstone rhyolite, to create rhyolite, you need to use approximately 50 to 70% basalt and 30 to 50% of crust. Mixing of these two components happens in a complex fashion in the lower to upper crust, where hot 900 degrees Celsius basalt magma tend to stall, crystallize, and differentiate, separate. The hot basalt magmas melt the surrounding crust and mix these two components together, producing a magma with an isotopic composition between that of basalt and crust. This hybrid magma then continues to crystallize or is remelted, then new basalt intrudes into the crust, producing the Yellowstone rhyolite. Like I said, I've been doing a lot of research and hoping that my brain can keep it all in. And once again, this is the image of the mixed basalt and rhyolite. Like they said, it looked like a marble cake. So I want to go to the Pitchstone Plateau. Alright, let's go down over here. Another thing that I found that was really interesting, this formed about 70,000 years ago. Let me come out, bring this out, because there was another, I believe this was the eruption. It formed later. Magma had pooled and come up, and then 70,000 years ago, there was this eruption outside of what they considered the caldera. All right, here's an interview from 2020 with Robert Smith, or Bob Smith, of the University of Utah, and they were talking about the uplift that was going on. That does not mean that a pending volcanic eruption is coming. But remember, we've had 30 or so smaller but still explosive eruptions since the last giant eruption 630,000 years ago. The youngest only 70,000 years ago that occurred on the Pitchstone Plateau. These post-caldera eruptions were smaller, but they were 10 to hundreds of times bigger than Mount St. Helens eruptions. And based on Bob Christensen's USGS work, they increased in frequency around 125,000 years ago, but there's been no volcanic eruptions for 70,000 years. No giant eruptions, but there has been lava flows, some as recent as 8 to 10,000 years ago, just that they were not an explosive eruption. So this was caused by dike intrusion. A dike formed, a crack formed, and yeah, then it erupted. So anyways, that's all I have for you right now. What I did want to mention there, up at Grizzly Creek, there used to be a monitor up there, and they don't have it anymore. And because that was probably the area where the eruption started for Yellowstone. I'm trying to go around here and look. Yeah, I talk about how it started up in the Madison River, Norris Geyser Basin, and it did its unzipping. And because this is the area where they've got so much mixing of basalt and rhyolite, yeah, you would think, yeah, they would keep these up and running. Is that it? I don't know. What's that one? No, that's the Teton Pass one. But it's not a borehole. Yeah. So what are your thoughts? Put your comments down below. Thank you very much for watching. Thank you for subscribing. Always be prepared for a disaster. Please stay safe, and I will talk to you later. God bless you. Bye.